Hello, welcome to section 8.5. We're going to talk about interpreting data. So by that, we're going to talk about measures of central tendency and spread of data. So if we're using that mean, we're going to use standard deviation to measure spread. If we're using the median as a measure of central tendency, we would use the IQR then to measure the spread of that. So we're going to do that based on the data distribution, talking about if data is skewed or symmetric. So we're only going to go through two examples. The second one, notice, has stem and leaf plots, and the first one is just a regular data set. So what I'm going to do is go to the calculator right away, and we'll enter the data in and determine if, when we make a box and whisker plot, if it's going to be skewed, symmetric, whatever. So it says calculate the most appropriate measure of central tendency and spread for this based on the distribution. We're going to include outliers in this, so we'll make a box and whisker plot. Again, if we have outliers, it means that our data would probably be skewed in some direction. So we'll kind of go from there. Stat, go to edit. I already have some data in here, so I'm going to clear that out and enter in these data. So 0, 2, 3, 4, 4, 5, 5, 5, 6, 6, 8, and 9. So 12 data points. I'm going to go to stat. We're going to go over to calculate, and I'm going to get all these one variable statistics. So I'm going to copy these down, and then we'll talk about the spread. We'll make a box and whisker plot. We'll calculate the fences and all that good stuff. So I have a mean of 4.75, a standard deviation of 2.35, and I'll get my 5-number summary here. My minimum is the value of 0. I have a quartile 1 of 3.5, median is 5. Which is relatively close to the mean. So if the median and the mean are pretty close together, it means that our data might be symmetric. But again, we'll have a way better idea once we make that box and whisker plot and we look at how long those whiskers are. So what I'm going to do first, let me copy these values down on here. What I'm going to do first then is copy these, and then we'll calculate what our fences are and the IQR. So let me take these down, and then I'll switch color. Again, the mean is associated with the standard deviation. My median would be associated with the IQR. So IQR, I'm going to take my quartile 3 minus quartile 1. So we're going to do 6 minus 3.5. And that's going to give me an interquartile range of 2.5. And again, it's pretty close to my standard deviation. So what we're going to do next is calculate our fences, and then from there we'll see if we have outliers. So my lower fence, in order to calculate that, I'm going to first take my IQR and multiply by 1.5. So I'm going to take 2.5 times 1.5. And that's going to give me the value that I'm going to subtract from the lower fence, or from Q1 for the lower fence, and add this to the third quartile to calculate the upper fence. So to get the lower, I'm going to take Q1, LF equals Q1 minus 3.75, and that is going to be, Q1 was 3.5, so take 3.5 minus 3.75, so I have a lower fence of negative 0.25, and then to get my upper fence, I'm going to take Q3 and I'm going to add that value of 3.75. And Q3 is 6, so that means to calculate my upper fence, I'm going to take 6 and I'm going to add 3.75, so I get an upper fence of 9.75. So if there is anything lower in my data than negative 0.25, which we can see there isn't, or if there's anything above 9.75, and again, we can see there isn't. So what that means is that we have no outliers. So I'm going to write that down. We have no outliers. So there aren't any of those really extreme low values or extreme high values, which means that our data is probably going to be pretty symmetric. So let's take a look at this. I'm going to just count by ones basically then. So 0, 1, 2, 3, 4, 5. 6, 7, 8, 9, and then I'll just put 10 up here. So make a box and whisker plot. I'm going to take my 5-number summary, which I had a minimum of 0. I had a quartile 1 of 3.5, so that's going to be here. My median was 5. My third quartile was 6, and then my maximum value was 9. So as you can see, it's a pretty symmetric looking data set. So when we talk about measure of central tendency, we're going to be using the mean value, because again, there aren't those outliers that are really going to drastically drag my mean to the lower end. There's no outliers that are going to really increase the mean to bring it to the higher end. So I'm going to get a little typed response down here. And I'm going to say, since the data is symmetric, we will use the mean for the measure of central tendency and the standard deviation to measure the spread of the data. So the mean in this case then, if I go kind of back up here, the mean was one of the things that our calculator knocked out for us. The mean was 4.75. So you have a calculated average of 4.75. And standard deviation, which represented that average distance that each point was away from the mean, your standard deviation was 2.35. So again, just to summarize this, because my data is symmetric, we don't have those outliers, we are going to use the mean for that central tendency, and then again, the standard deviation is the spread associated with that, so that's why we're going to use the standard deviation. With this next problem, I have two data sets. So what I'm going to do is analyze each data set first. We'll talk about the spread of each of these two data sets, and then based on that spread, we'll determine what the most appropriate measure of central tendency and spread would be then. So for this first data set, I'm going to take a look at this. I'm going to draw a little idea of what a dot plot would be underneath this. What I'm really going to do is just take a look at a curve. So notice that this would mean like 38, 38, 38, 39, 39, 39, 42, 45. So that's how we would use a stem and leaf plot, is you're taking this value to represent your tens place, this is your ones place, so this would be like a value of 51 or 55. So what you can see is I have a lot of values on the lower end. So if I had a value down here, let's say this was 30, and I went all the way up to 60, well, we have a lot more points on this lower end. So what that means is that my data would look something like this. So this would represent data that is skewed, right? And then if I look at this data, it looks like I'm going all the way from, again, if I were to put like 30 here and go all the way up to 60, it looks like we have kind of a peak or a cluster of data towards the middle. So it would look something like this if I were to make a dot plot, and our data would be symmetric. So what that means is that for data set 1, and that's what I'm going to actually just type out a response here. So since data set 1 is skewed, right, we will use the median as the measure of central tendency and IQR to measure spread. Data set 2 is symmetric, which means we will use the mean as the measure of central tendency and the standard deviation to measure spread. So based on that dot plot, or just this little drawing that I have down here, which you don't even have to make these drawings, you can really see that data set 1 has a really big peak at the top here, which means that your data will be skewed. So since this data is skewed, we would use the median, and since this data is symmetric, we would want to use the mean. And again, the reason for that is that these values are going to be representing like a lot more of your data. This value of a 60 down here, what that's going to do is take your mean and it's going to increase it because this value is a lot further away from the peak. Since your peak here is really in the middle, it means that there aren't any really low or really high values that are going to drive your mean away from that. So that's why we would want to use mean here, and we would want to use median here. So from that description, what I'm going to do is go to the calculator, and I'm going to enter this data in. Oops. Okay. So what I'm going to do is actually put both of these data sets in at one time. I'm going to go to Stat, Edit. I'm going to clear out my data that's in there right now. And I'm going to enter in both sets of data. So I'll enter in the one on the left first. And you know what? I'm actually just going to pause this video and then we'll kind of just pick up from there. So now that I have the data in the calculator, I put data set 1 for L1 and data set 2 for L2. So what I'm going to do is go to Stat. We're going to go to Calculate. And I'm going to calculate the one variable statistics for L1. So we're going to take a look at data set 1, which we said is skewed. So since it was skewed right, what I'm going to do is really focus on the median for my measure of central tendency, and then we will calculate the IQR for the spread. And what you could see, if we were to look where the mean is, my mean is 44, but I have a really big standard deviation that's almost 7. So kind of keep those numbers in the back of your mind, because when we look at data set 2, you're going to see a lot smaller of a standard deviation because your numbers are really clustered together around that peak in the middle. So let's take this down. My median is 42. And then I'm going to calculate the IQR. Again, this is for data set 1. In order to calculate the IQR, I'm going to take Q3, which is 49.5, and I'm going to subtract Q1, which is 38.5, so I have an IQR of 11. So again, your interquartile range is all those values that are like around that median value if we were to make a box and whisker plot. And again, I just took Q3 minus Q1, and that gave me my IQR. So that answers the part for data set 1. Now I'm going to go to Stat. We're going to go over to Calculate. I'm going to hit Enter here, but we're, for data set 2, going to push second and then a value of 2, because you can see where my cursor is right here in the right above the value of 2 we have L2, and what that's going to do is calculate all of our stats then for data set 2. What you can see then is that I have a median, or I'm sorry, we have a mean of 49.5. So that's a lot more where my data looks like. It looks like it's right in the middle of this. And we have that standard deviation of almost 8, which means that your data is about 8 units away on average from that middle point. So for data set 2, again, I'm going to write down what my mean is, which is 49.5. And I have a standard deviation of, and I'm going to do 2 decimals on this, 7.98. So again, this would be what we would use for data set 2. This was the one for data set 1. And again, I only did those based off of what we established right away at the beginning, that if our data was skewed, we wanted to use the median, and if our data was symmetric, we would want to use the mean.